Hi viewers, you are welcome to another episode on my tutorial videos on Staad Pro. In this video, I'll be showing you how you can analyze a 3D frame using Staad Pro. Okay, so let's start by creating a new project. Then you can create space. Let's give it space frame. Then you can insert you can select your unit for the length and the force. If you are satisfied with that, then click on next and then click on finish. Now I am going to use a different kind of method of analysis. I'm not going to use the noder, so I'll go to geometry so that I can run the structure wizard. Then I can go to frame model. Then I can go to bayframe. I don't need to give it a name, but if you are so concerned about the name, you can give it a name. Then here I'm going to choose 10 meter. The height I'm going to choose 6 meters, and the width I'm going to choose 5 meters. Okay, then the length along the width I'm going to have 4 meter. So if I use 4 meter, that means for each span of the beam that will be 2.5. okay, if you don't want them to be equal, you can come here and then you change them, but make sure that anything you change here, everything still needs to add up to 10. okay, but 2.5 plus 2.5 in 4 places, that's still 10, so I'll leave it like this, equally spaced. Then for the height, I'm going to have two stories. Okay, so along the length I'm having 4 B's. That's what I just did right now. Okay, then along the height, which is the story, I'm having 2, and then along the width I'm having 2, so that each one can be 2.5. Then you can click on apply, and then you can click on close, then click on yes. I want it to be at the origin. If you don't want it to be at the origin, you can select, you can edit the position, but this is what I want, so just click on OK. Now we have the frame, as easy as that. Then the next thing will be to go to the geometry, to go to general, then you go to property. Now this is a frame. A frame definitely consists of beam, and then column, and then slab. So for this particular structure, I will include slab as well. So let me go back to geometry, then let me insert slab. So let me put it in front view, and then I'm going to cut the top view so that I can only have the bottom view. And then so to do that, you just come here. This is cut section. Then you go to select to view. Then I can use this. Click on OK. Then just drag it like this so that I can select the bottom story alone. Then you can see only the bottom story is highlighted. Then let me see it in isometric view. Okay. Now I'm going to draw a slab. Now this is the slab I'm going to draw. I am going to use this one. I'm going to generate a surface mesh. So to do that, you click from this point up to this point, up to this point, up to this point, and then you're going to click the first point. Okay, then it will ask me the kind of mesh I want to do. I'm just trying to mesh it, so I would prefer a quadrilateral meshing. Okay, because that is 4. It is a rectangle, it has a 4 angle. So click on OK. Then AB is the first distance. The total length of AB is 10 meter. Now it is asking me how many divisions do I want. So let me just pick 10, so that for each mesh, no, let me use 20. The length of AB is 10 meter. Now I'm using 20 divisions. That is, it should mesh it in 20 places along that length. So that is like 0.5 meter for each length. Then this one is 5 meter. So I'm going to have 10. Okay, so that is still 5 meter, right? Then this one I will have 20, and then this one I will have 10. Okay, so that is 0.5 meter meshing. Then you can click on apply. Then you can see how the mesh is looking good. Let me click on the whole story. I only cut the bottom story. Now I need to show everything, so you have to click on this icon so that you can display the whole structure. Click on it, then you can see we have a slab here, but we don't have a slab here. But to make it easy, I will just generate the slab I have at this story and then generate it up. Remember that the height of one of the story is 3 meter. You can still confirm that. You can click this one so that this is what will display the node to node distance. Then measure what is the distance from this node up to this node. You can see it here. That is 3 meter. Okay, so that is doing good. Now all I just need to do is select this slab and then copy it upward. I can use the translational repeat. So to do that, definitely you need to pick the slab, what is it called, the plate cursor. So just select that, and that will select all of the plates. So this is the plates. Then you can go to translational repeats. Then you go to Y, because I want to translate it in the upper direction. Then how many number? Just one number. And then what is the distance? That is 3 meter, not minus 3 meter, but 3 meter. Do I need to link this step? I don't need to link the step. I just want to copy the slab. Then click on OK. Then you can see we have another slab at the top. Let me try to select everything. You can see what we have. That is looking good. So let's go to general tab. Then in the general tab, now we are going to give them the dimension. So you go to property, and then you go to define. So I'm going to have two different sections. I'm going to make my column to be a circular column. So I'll make the diameter to be 0.4 meter. That is the diameter of the column. Or let me use 0.3 meter for the diameter of the column. Then click on add. Then I'm going to use a rectangular beam. So this one that I'm using for rectangle, that is beam. This one that I use circular, that's what I want to use for the column. So click on rectangle. Then I want the beam to be YD. This is the YD. I will make that to be 0.45. Then I'll make the ZD to be 0.225. So that is a 225 mm by 450 mm. Then click on add. So that is doing good. So I have the dimension. This is the dimension. This is the section I want to use for the column. This is the section I want to use for the beam. I also need to create another section for the slab. Okay, so to do that, you won't go to define, you go to thickness. So go to thickness, and then you are going to pick the plate element thickness. Okay, there is plate and there is surface, but we're not doing surface, we are doing a plate. So click on plate. Then node, for each node, I want it to be the same. At it being you want a kind of ramping slab, a ramping slab that's one side will be thinner while the other side will be higher. Then you need to give them different dimension for the node. But since I want everything to be equal, I'll just give the same dimension for them. So for node 1, I'll say it is 0.15 mm, and everything will change. Okay, but if you don't want them to be equal, you can come back here to change this one to be, let's say, 0.75, and then this one is 0. Whatever, you can just change them. But no, everything should be 0.15. Then click on add, and then close. That is looking good. Now I just need to assign them. So for this one, which is circular, I need to assign to the columns. But now, how do I select the columns? I am going to do that in a very easy way. Just go to select, and then you go to beam. If you remember in the first video, I told you that beam is still the same thing as column when you are modeling, in as much Staad Pro is concerned. So I'm going to select all of the beams that are parallel to the y-axis. Remember that all columns are vertical, and vertical is y-axis. So all of the columns are parallel to the y-axis. So I'm going to select all of the beams that are parallel to y-axis, and that is definitely the columns. So now you can see that all of the columns have been selected. Then you can click assign to selected beam. Then let's click on assign. Yeah, assign. So all of the columns have been assigned. So this dimension of 300 mm diameter is assigned to all of the column, just as that, just as simple as that. Then I'm going to assign for the beams. So click on this one, which is supposed to be assigned to the beam. You go to select again, and then I'm going to select beams that are parallel to the x direction. You can see that all of the beams that are parallel to the x axis have been selected. Then you go to select again, select the beam that is parallel to the z again. Then you can see now all of the beam have been selected. Then you can use this assignment method. Then click on assign. Yes, now all of the beams have been assigned to. Now what's next is the plate. That is simple. You can just use your plate cursor, then you select all of the plates. That is very easy. Then you use this same assignment method, which is assign to selected plates. Then click on assign, and then yes, now all of the plane has been assigned to. You can check the 3D rendered view by using this icon. Then it's going to show you the rendered view. So this is how the view looks like. Okay, so this is how the structure looks like. So you can navigate as much as you want. So you can see that the column is a circular column. You can see the column is a circular column, and then the beams are rectangle, and then the slabs and everything. So just as simple as that. So you can close the rendered view by closing this one, not this one but this one. Close this one. Since this is done, we can now assign the support. So go to support, and then you can create, we only need to create fixed support in this case, then click on add. Let me put this in front view. Now I'm going to select this support, then just select all of the bottom column like this, which is these 5 nodes. But when you select these 5 nodes, let me put it in isometric. You can see all of the nodes along all those sides have been selected. Okay, then you can click on assign to selected nodes, click on assign. Then you can see that all of the nodes have been assigned. Then the next thing now is the load. We need to define load. So you go to load and definition, then you go to load cases, go to add. Then let's give a name. Let's have dead load. Then here I'm going to pick dead, add. Another one, let's call that live load. Then here pick live and then add. I'm going to have a combination. I'm going to define a combination. Okay, then I'll take these two to come to this side. Now this one, which is load case 1, load case 1 is supposed to be dead load. I'll multiply it by 1.4. that is a multiplication factor. And for load case 2, I'll multiply it by 1.6. So I'm multiplying all the dead load by 1.4 and I'm multiplying all the live load by 1.6. So that is definitely what I'm doing here. Then here I'm going to change the name. Let me call it ultimate limit states. So that is what I want to do. You can definitely work with your own dimension, with your own loading factor. It does not necessarily need to be mine. Okay, but this is the load case we use when we are designing according to BS 8010. Okay, so and then you can add that load combination and then you close. Now let's go to dead load and add. Now under the dead load, the only thing I'm going to add is the self weight. So under the self weight, just click on add. You don't need to, there's nothing to do here. Just click on add. And that will get added. Then you can close that. And then you go to live load. Under the live load, click on add. Then then you go to floor load. This floor load is the load I want to apply on the slab, and that load can now get distributed to the beam. Okay, the slab is what people will stand on and then walk on, whereas the load from that slab we can now get distributed to the beam and then to the column. So that's why I'm going to the floor load, floor as in slab. Okay, and then the pressure, which is the load per meter square, I'm going to use minus, let's say 2.5 as in residential building or any kind of building. I'm just using a particular value. Okay, and then I'm going to define a range. I won't select this one. If you want the load to be, if the slab is supposed to be a one way, then you have to click this, but it is two way, so I'm not doing this. It is asking me for the y range, the range in the y axis. Now where do I have the slab? I have a slab at 3 meter and I also have another slab at 6 meter. So I can say that the minimum point is 0 meter and the maximum point is 6 meter. As simple as that. Then you can click on add. So that is there now. This is it. We can see the Y range. I'm going to add another load. That is going to be a member load. That's the load I'm going to add on the beam to represent the the wall load. I mean the load of the wall. So I'm just trying to add as many as possible loads. And then here, let me use minus 1 kilonewton, and then let me just put this at 0. So that should be the load to load. And click on add. And then close. Now let's start assigning the load to all the elements. This first one, which is the self weight, I'm going to apply the self weight to all of the members, because every member will have their self weight. The beam will have self weight, the column will have self weight, the slab will have self weight. So I'm going to use assign to view because it's everything here that will need self weight. So click on assign, then yes. So you can see everything has been added to it. So this is how its self weight will be added. So this is good. Then the next one is the this one. Which is supposed to be this one has been added already. You don't need to assign anything. It knows what to do. Since you've defined the range, it knows what to do. Then this one, this is the uniform load that I want to assign to the beam. To do that, I'm going to assign this to the beam alone, so I can just select all of the beam. So go here and then say beam parallel to X. I want load there. I want them selected. I also want the beam that are parallel to beam parallel to Z. So all of them have been selected. Then I can click assign to selected beam and then click on assign. Yes, then you can see the load in blue color, so the loads too have been assigned. So now I've successfully assigned load to the beam. I've also loaded the slab, so you don't need to load column. We've loaded the column with self width already, and the load coming from the slab to the beam will definitely get distributed to the column as well. So now we've loaded it. The next thing now to do is to analyze this. So to analyze it, you know what to do. Just go to analysis and print. Then you can pick any of this. Let's say no print. Then click on add, and then close that. After you are done doing this, before you run the analysis, make sure that what you have here is the load you want to use to analyze. This is the live load. Remember, I have 3 load cases. I have the dead load, I have the live load, and I have the ultimate load limit state. Remember that the ultimate limit state is a combination of load, which is this dead load and live load, and then I also multiply it with the factor. So I want to use this ultimate limit state to analyze, not the live load. So click on this. So this is what I'm going to use to analyze. Then you can now go to analyze, run analysis, and then let's wait for it to analyze. Okay, good. The analysis has been completed. We have a 0 error. That is good. We have 0 warnings and we have 1 note. So it is telling us to note something. That is not an error, nor is it a warning, but it's just a note. So let's just see it. It's not going to be a problem. It's going to tell us about the one-way, two-way load. So click on it. Now you can see it says, please note that depending on the shape of the floor, you may have to break up the floor as one-way load into multiple commands. Okay, it is telling us that at times the load may not need to be distributed as two-way. It may be distributed as one way depending on the shape, but that is not a problem. Okay, so close that. Then you can check your post processing, and then just check your let's see the moment diagram. Let me maximize this. Let's hold control so that the diagram can be visible. Okay, I think this is visible a bit. Then you can go to results, and then you view the value for the moments. Let's see the moments at the end. Okay, so this is how you are going to see this. Okay, but this looks a little bit clumsy. It looks a little bit clumsy. So at times what you may need to do is you can just go to post processing and then double click on that particular beam you want to select. Let's say this beam, then double click on that beam. Then when you double click on that beam, you can now come to shear bending. You can also change the load case to ultimate limit state. Okay, then you can check the bending. This is the bending. If you want to check the bending, you click on bending in the Z direction. Then this is the bending moment diagram. Okay, if you want to check the shear force, this is the shear force. If you want to check the bending in the Y, this is it. If you want to check the shear in the Z, so this will make you to to check the result of the beam without having to check everything at once. If you are checking all of it together, the drawing may be too clumsy for you to review, so you may just need to double click on the beam and then check the results one by one like this. Okay, so that is very good. So this leads us to the end of the video on the analysis of a 3D frame. In the next video, we will be designing the structure. We've modeled the structure, we've analyzed the structure, we only need to design it. So thanks for watching up till the end, and if you haven't subscribed to my YouTube channel, you need to subscribe to my YouTube channel, and you can on the bell icon so that you can see my notifications whenever I post a new video. Thanks for watching.